Now go ahead and go into Visual Studio. So you click your Windows and this one right here, Visual Studio 2017. You can also search for it. We started talking about some various programming constructs last time. To hurry up. Okay. Um, Remember variables, integers, numbers with no decimals, doubles, numbers with decimals, Boolean, true, false, string, mixture of letters and numbers. Now over here in Microsoft Visual Studio, do your file, and then do new project. Now there's a bunch of different ones here. There's a Visual C, looks like pound sign, that's Visual C Sharp. So go ahead and expand that if it's not already expanded. And these are all the things you can program. You can program a Android app, Apple TV, Apple Watch, cloud, cross-platform, iOS extensions. So a lot of different flexibility there. The one we want is consoleapp.net framework. So choose that. And you can give it a name if you want. Doesn't much matter with what we're doing here. And then click OK. We talked about this before. Just bring in what you want. So again, that's comes up with some defaults, and then you can add in other items that you might think you need. Got our namespace here, console app 3. That's what we named it. And then class program. Remember we talked about that Star Wars game before? And so this is an object. And then we got our void main. Void means nothing's returned. We're going to see that a lot more. And don't worry about the rest of those arguments, and parameters, so forth. Okay, so let's program. Let me bring up some formulas. Physics formulas. And we're going to program. What are we going to program? Kinetic energy. That might be good. Kinetic energy is 1/2 times m times v squared. Now, different programming languages, you have to handle that differently, but that's where we're going to plug in. Now, the 2 slashes here indicate a comment, and I'm going to write the formula down. So K equals 1/2 mv squared. We talked about this before. You know, you go. I'm going to calculate kinetic energy. I guess K is kinetic energy. We're going to calculate it. I come up to somebody. I have to tell them what I'm going to do, right? If I come up and say the answer is 5, well, I'm missing a lot. I've hard-coded some values and so forth. So we'll do a console.writeLine. As this is popping up, and that code completion window's coming up, you can use your down arrow key to choose one. That's the idea behind code completion, is that you don't have to have this all memorized. You know the first 1 or 2 letters, and it'll pop up the list. You can do a down arrow and choose it. Now, after you choose it, you can do a tab, and it does the code completion. And then we'll say program to calculate kinetic energy. Well, I need to declare some variables. And I could declare them here, but I'm actually going to go up and do an enter on console and put them up here. I think good programming practice indicates you put your declarations all up at the top, but it doesn't matter. Why it's, I think, beneficial to put it up at top is that you know where it's at. It's like, well, where did I define this at? Well, you define it at the top. It's always up top. M, V, and K. What kind of variables do you think those would be? What kind?
K, kinetic, right? It would mean kinetic.
Right.
Also dancing. I'm not sure what it would be.
Probably doubles, because they probably have decimals, right? I'm guessing M is mass. So if you measure, it could be 200.3 or 100.1. Velocity, that's not going to ever be an integer. It probably has decimals, right? You're going 30.23. So we do doubles. And you could actually use those letters if you want. You could use K, M, and V. Now, I put those all on one line by putting double first and then each variable name separated by a comma. Now I need to ask the person what is the mass. So I'm going to do a console.writeLine. And I'm going to say, what is the mass? Again, notice that each one of these is ending with a semicolon. Good so far? Now, if you get any red squigglies underneath, that means you've done something wrong. People in another class, they would forget to put the semicolon. They get a red squiggly. They'd forget to put a closing parentheses or closing quote. Again, you get a squiggly indicating you got an issue. Now here I'm going to say M is equal to, and then I'm going to do console.readline. But we're going to see an issue with this. Beginning parentheses, closing parentheses, semicolon. Now I move my mouse down to the next line, and you see it's got that red squiggly underneath. Sometimes you can put your mouse over it and it's meaningful. Sometimes it's garbage. If I put my mouse over it, now it tells us reads the next line of characters, cannot implicitly convert type string to double. What that's implying is that this is a string, returning a string, but we declared this as a double. Double is where you have a number with decimals. String is where you have alphanumeric. So here at the beginning, I'm going to do a double dot parse, and then beginning parentheses there, and over here at the end, I'll put a closing parentheses. What is this doing? Well, when this does the console.readline, then whatever you type on the screen and when you press enter, the console read line is bringing that in. It's bringing it as a string. And then this double dot parse, that's taking the string and converting it to a number. Hopefully you actually put a number in. If you put an alphabetical character of some sort, it'll blow up. Then down here, I'm going to do console.writeLine. And I'll say, what is the velocity? Then v is equal to double dot parse. And then console dot readline. Now, different programming languages handle this differently, and I don't know how C# handles it. But if I do a k equals 1 divided by 2 times mass, which is m, the asterisk is multiplication. And then times, and we got v squared. Well, how you do a squared in C# is you type math dot pow, that's short for power, and then you put in your v comma 2. Good so far? Okay. Then we're going to print it out. I don't know if this will work, but we'll see. We'll do console, and I'll choose just write. And I'll say the, what are we finding? Okay, what was that? Kinetic energy? It's been so long since I've had physics, I couldn't even tell you what these represent. The kinetic energy is equal to. Now, this is a user-friendly message we put on the screen. And then we'll say console.writeLine. And I'll put in K. Okay. Did anybody got any red squigglies? No. Now, if we come up here and we do a debug, start without debugging. Our program comes up and asks us what is the mass. And so we'll put in, I don't know, 200.2 or something like that. It'll come up and ask us what is the velocity. So I'll put in 30.1 and press enter. and we get kinetic energy is equal to 0. It's probably not right, is it? Don't know much about physics, or I don't know anything about physics, but I'm guessing that's not right. Remember how earlier I said it may not work? The reason why is what's 1 divided by 2? 0.5. Assuming we have decimals. What's 1 divided by 2 with integers? Ignoring the remainder. Now, let's see. If I'm doing my dividing, so we got 1 divided by 2, old style division. How many times does 2 go into 1? 0. So you put 0 here. Then you take 0 times 2, which is 0. One minus 0 then gives you 1. So my answer is 0, remainder 1. Now, integer division, this is what's returned. So when this is doing the 1 divided by 2, what this is doing is it's giving us 0. And then 0 times whatever we put in for m is still 0, times this still is 0. Way to change that is you can simply put a 0.0 there. We might have to put it on 2 also. But that's real common in a lot of programming languages. It doesn't know whether you want to do double division, where you have decimals, or integer division.
I've noticed that when I've been typing, like if I put parentheses or something, there'll be a black bar over it, and then if I type something underneath, it's like, can you
Let's see.
okay, so parentheses, black bar right there. It's like somebody's on that black line because I'm trying to fix things. I don't know what to do.
I do backspace a couple times. And write console.write line. And do beginning parentheses. And type K. Fair enough. It just deletes it, doesn't it? Huh. I don't know. Let me think about that. I've never seen that before. Code completion is such that when it puts it there, I wonder. Let's see. Console.write line. Beginning parentheses. There, I know what it is. Your insert's on. If you push your insert button key one time, now I bet it'll work.
Yeah, it works now.
Okay.
Thank you.
I was thinking, wow, I wonder what setting this is under. It's like, no, this is much simpler than that. Okay. So now if I do my project, or wait a minute, debug, and do start without debugging, probably it's not going to say 0 anymore. But let's see. Put in 200.5, put in 30.2, tells us kinetic energy is equal to that. So sometimes you have to play some tricks with it in order to say this is not an integer, this is a double. The 1.0, what it's seeing there is it's seeing, okay, that's a double divided by an integer. And so it includes the decimal places. Some programming languages, you don't need the 0.0. So there's no rhyme or reason. You just, if you get a bizarre result, look for that. Good on that? Okay. Do you want to see another formula, or you feel good? Okay. I'll show this one. This cosine, rotational power. I'm gonna say that's a T and that's a W. They're not. I don't remember what they are. If you take physics. Yeah, I don't know. Doesn't matter. But we got T, and then we got W, and then we got this theta over here. A little O with a line going through. Okay, so we're going to figure that. So I'm going to save this. So you can do a file save all, or you can click the little button here with two icons. Then I'll do a file close solution, and do a file new project, and choose this console app. You can give it a name if you want. This is calculating. What is this calculating? Rotational power. So I'll call this rotational power. Now notice the location here. Did we create any of these last time? We didn't create any of these last time? Okay. In this morning's class, there were some issues when we saved it to the documents, and we tried to zip it up. It wouldn't let us. So that's why I was wondering if we actually got that far last time to zip up something. So a safer bet might be to do a browse and change it to your desktop. Mm-hmm. Should we, maybe I haven't used desktop. That's interesting. Okay, I'll click this PC, and there's my desktop. And I'll click select folder, and then we've got a rotational power. Now, it's still going to create a directory for the solution, so it'll create a new folder out in your desktop. And hopefully this will allow us to zip it up, because I want to demonstrate that. And then you click OK. Now this right here, this tells us what variables to use. Probably, what are they all going to be? Doubles? Yeah. I'm guessing that I don't know what, that weird T looking, I thought it was tau, but I don't know. Is that omega? Little W? I don't know. I don't know what they are, but I'm guessing they're decimals, or I want to make it so they're decimals. But definitely cosine. Has anybody had any trig at all?
You don't have to have trig, but yeah, I've used cosine before.
Okay, it always gives you decimals, right? Well, not always, but almost always. So yeah, we want decimals, which means everything will be a double. So I'm going to have T, W, and theta. So I'm going to declare it. Double is T, W, and theta. And I'll actually spell out theta. You do not have to have one-letter variable names. One-letter variable names is actually bad programming practice. Now I'm going to say what I'm doing. So I'm going to tell the user this is program to calculate. I got my insert on. To calculate, what are we calculating? Rotational power. Now I need to go and ask the user for information, so I'm going to do another console write line. And I'm going to say input W. Now this is going to be a double, so we're going to do a W equals double dot parse. Do a beginning parentheses, and I'll do my console dot read line. Beginning parentheses, closing parentheses. Now these little green squigglies underneath, that means something potentially is wrong. That won't stop it from running, but it's something maybe you should pay attention to. Now I did have a little green squiggly underneath my W, and it disappeared because I've actually done something with it. If I put my cursor over the theta, it says the variable theta is declared but never used. So down here, I need to bring in theta. So say console dot write line, and I'll say input theta. And then I'll say theta is equal to double dot parse console dot read line. So that's putting in our theta then. Okay, so now we're brought in W, we're brought in theta. We're ready to do our calculation. Our calculation is T times W times cosine theta. So, am I calculating the wrong thing? What am I supposed to be calculating? TW theta. Oh, I need to bring in another variable, don't I? So I got W, I got theta. So now I need to bring in T. So I'll have another console.write line. And I'll say input T. And then T is going to equal to, it's a double again, so I'm going to do a double dot parse. Console dot and read line. Beginning parentheses, closing parentheses, like this. Okay, so I brought all those in. So now I'm ready to calculate rotational power, which is P. So actually what I need up here is I need another variable, P. So P is going to equal to T times W. So T times W times, and this is a cosine. When you're developing a 2D game and you have something bouncing against the wall, a very easy way to handle it, so you can use some of the features of the program to do it automatically. But if you're trying to have more control and you're doing it from a programming standpoint, one way to do it is just change the direction, or the not the direction, the sign, from positive to negative. So if you're incrementing it by something, which we haven't talked about yet, then it just goes in the other direction. Now, have you ever played those games where it bounces against the wall and then it comes back at a different angle? So that there's places where you'd want to use sine and cosine so you can get a particular angle. And we're going to talk more about that. In order to understand some of the basics of movement, you have to be introduced to a little bit of trig. So we will look at that so you understand how the movement can go. Well, I'm going to do a math dot cosine, then beginning parentheses. Now this is right here. It's very specific. It says an angle measured in radians, which means I cannot put 30 degrees in, or 45 degrees if you're familiar with that. That's not the same. If you put 45 in, it'll assume it's in radians. Did they cover radians at all when you cover trig? Radians is where you go all the way around a circle, like a 360 degrees. That's 2 pi, or about 6. So 45 degrees, if you just put 45 in, it'll go around, I don't know. If you take 45 divided by about 6, that's how many times it'll spin around total. But for now, I'm just going to simply put in my angle. So I'll put theta in. We'll come back to that. And then I want to print out my result. So I do console.writeLine, and I'm going to print P out. And then I'm going to click Start. Pops up and asks us for W. So we'll put in whatever W is, 23. It asks us for theta. And like I say, I might think I'd put 45 degrees in. So I put 45. And then I put T, and I put 2 in. I didn't do it right. You need to do a debug start without debugging. Sorry. Okay, let's try it again. Put 200 in for W, 45 in for theta, and I'll put 3 in for T. Comes out and tells us that our answer is 315 point and then a bunch of decimal places. Good so far? Now, on Tuesday, where we're headed with this, now that we're learning some of the sine and cosine, is we're going to be doing character movement on that screen we looked at in Unity, where we drop on. You ever play that game Meteor, where meteors are flying around the screen? It's a real old one. But you have them go into different angles. And so you can do a lot of different things with that. Now, sometimes programmers don't get that excited because maybe their math skills are weak. And the meteor game is such, if you shoot the meteor, it breaks into pieces. And they go off at different angles. Let's see if I can find a video of that. Does anybody know what I'm talking about?
I think I know what you're talking about. Yeah. At the more that we used to have this little game,
Uh-huh.
a little desktop game, and it had like a bunch of different games on it. One of the games that had on it was this meteor game where meteors would come down and you'd have to shoot them.
Oh, that one. That's Missile Command, actually. That's a cool game. The arcade one is where you got the little pad you roll around and then you. Meteor game. I wonder if that. Hopefully, there's no bad images. Meteor arcade game. That's got to be better. Okay. Okay, now let me go to videos or images. Maybe you know what I'm talking about if you've seen it. This is kind of it here. This is kind of an updated version of it. The original one isn't that good. Here's the original one. Here it is. You got these meteors coming around your screen, and when you shoot them, they break apart and go off in different directions. Well, the idea on that, there's different ways to do it. Some game development packages have a element you can add to control that, like throw randomness in it. But your idea is you can go off at any angle. Probably you want to design it such that it doesn't come right back toward the ship. That'd be kind of frustrating, right? You shoot the meteor, it breaks apart, but then it keeps on coming toward you. The idea of the game is they go off in any other direction except yourself. And that's what you have to think about from a design standpoint. How do you want to design it? Okay, so this comes up, says to press any key, so we'll press the enter to get out of that. And that's calculating rotational power. Now, I said this has to be in radians. And we really haven't talked about what radians is, except for just generally all the way around circles, about 2 pi or 6. Now, you can do a math here, dot, and this brings up a lot of different options you can choose. And I don't see radians there. Let me do angle. Angle. Let me Google it. Obviously, I don't remember the function. Okay. C sharp function. We're going from degrees to radians. I could do it by formula, but I was hoping to use the actual function. Maybe there is no function. This is the mathematical formula, by the way. You multiply it by math.pi divided by 180. Um, Not saying that the author is correct, but that'll work. Um, just to briefly go over it. When you got 45 degrees, like this right here, there's a concept of dimensional analysis where you put it over 1. And if degrees is up here, degrees has to be down here. And then our radians would be up here. And you're looking for some kind of connection between degrees and radians. And 180 degrees is equal to pi radians. Or 360 degrees is equal to 2 pi radians. So then the degrees cancel there. You got 45 pi over 180. Or basically, you took 45 times pi over 180. So that's the formula to convert. If you were programming a game where you had to put in the angle, like you have to input the angle to try to shoot something, and you put in 45, then from a programming standpoint, you'd need to figure out how to convert that. I'm surprised there isn't a function for that. Okay, so here I'm going to put in, we said we're going to take our theta times pi divided by 180. Now pi is achieved by doing math.pi divided by 180. Now what I'm going to be doing through the rest of the semester is teach you a little bit as we go along. So no, we're not going to cover all the mathematics you need for a 2D game. We'll just introduce it, as we hit each individual piece. And since we're getting ready to talk about movement next class, and that's where we're discussing that. So now if I do a debug and start without debugging, you notice it also says Control F5. So that's why you can fire that off. So we're going to input W. So put in 300. Input theta. This is where I can now put 45 in, and T I'll put 2. And that would I can put in 45 degrees, and it converts it to radians for me. Questions on that? Well, go ahead and close that solution. So do a file, close solution. And go back to your desktop. And hopefully this works. Hopefully it isn't the entire machine. You should see a folder there of whatever you called your project. Now, if you double click that folder, it's going to take you here. And you got another folder that says rotational power, and you should have one that says rotational power.sln. Now you share your computer with other people in other classes, so they might have shut that off on you. But you should see your extensions there. If you do not see your extensions, you come back up here to the view, and you click this one that says file name extensions. You always want to be able to see your file name extensions. People make a mistake when they turn in their projects. They'll turn in just this one file here. And that's nothing. It's a placeholder. It says, okay, here's what's in my project. So if you turn that in, I won't be able to see anything. Now, if I double click rotational power, you're starting to get into more of the different items here. And trying to remember, I think I showed you bin, didn't I? The bin directory where you can run exe. Yeah. So again, that's there. Okay, so I'm going to close this window. Now back here at my desktop, I can right click on this and choose send to compressed folder. File not found or no read permission. Okay, so it's just not that one directory, it's everything. That's nice to know. Another thing to look at on Friday. I'd be shocked if I actually got through the entire day without something not working right. We put it before we put it in our documents, which everybody should have access to your own documents. But I may have to install another zip folder. This almost implies that the compressed folders program is not working right. Okay, well, I won't show you zipping up a code today, but now I want you to use one of these. Let me find one with a trig function in it, since we'll be using trig. Thermal physics. Figure this. Do this work problem right here. Now, in case you're wondering, what does this mean? This F with a bar over it is usually referred to as F bar, but just call that F. This little triangle and then an S, just call that S. Those are actually together. That's delta S, and it represents change in. So you're going to have F times S times cosine theta. So go ahead and write a program that gets those three items from the user and then calculates work and prints it to the screen. Never knew there were so many physics formulas. you're not sure where to begin or you're stuck, just holler at
What's that, that's the one?
me. FS and data. I do need to declare them what data type, so you have to put like integer or double in front of it, int or double.
So that would be a double one.
That'd be a double, exactly. And then at the end of the line, you gotta have the semicolon. So our formula is W is equal to F times S times cosine of theta. Should look almost um, exactly like what we did before. So I'll put this up if you need to use that as a pattern. One of my items on the list tomorrow is to figure out how for you to print to the printer. He gave me the IP address. I just never have set up a printer with an IP address before, so I'll experiment with that tomorrow. That way, when you do sample code, you can print it off and have it on a piece of paper next to you so you can see. We'll see the eye doctor tomorrow, so we'll be able to get some glasses that aren't blurry or scratched. All right.
I'm currently waiting for that, so.
Yeah, it's just like I'm walking around in a blur. Even cleaning it doesn't get rid of whatever I spilled on it. told my wife, I said, I think I've had an eye stroke. And I probably won't be able to go and work anymore. I'll just have to sit at home and play Call of Duty all day long, and she'll have to go back to work. She didn't quite see the humor in that. For the cosine, you put your math dot cos. Oh, cosine theta. Yeah. Some game pack development packages now used to be you had to check for your own collisions in some cases, but some of them have added special libraries, special bits of code where you add it in to your development environment where it checks for collisions. There's a real clever 3D game they created in Unity. I think it was in Unity, where you could run through, and it was a math tutorial. And you run through, and then it would stop you at certain points, and you'd have to solve math problems. And by solving those math problems, it gave you additional. It was coins it gave you, and those coins allowed you to open up the doors. And it was one they actually sold to the school system. That's where I got found the name of it. I think Wichita was using it in some of their schools. Have you ever seen like something like that in your schools? No. Yeah. What they found is that by making learning fun, that people's math skills increased, and that's what you always have to look at the end result. You know, if your end result is people's skills are better in terms of basic numeracy, that's what you need to go with. What I bring that up is I was real curious how much money they made off that game. Because I'm sure they didn't just sell it just to certain schools in Wichita. They sold it to, all across the country. What that's big brains. I may be confusing that with another game. Big brains. Yeah, I think it's big brains. Um, Imagine learning that they built with Unity, and you go through and see you have to solve math problems at certain points, like 5 times 2. And it depends upon the game, I suppose, but it gives you like coins where you can continue on or open doors and so forth. And they say people achieve 94% fluency up to 6 times faster in these grades. Um, yeah, I'd be really interested to know how much these people are making now. It looks like they have a where you can sign in, and maybe you don't even have to install it on your PCs. Um, I don't know if that's true. You probably have to install certain Unity. It's got progress reports.
What do you put up?
Oh, sorry. You get it? Okay. And after he finishes, I'll have you both run it and put in the same numbers and see if you get the same answer. So that way,
Finish mine.
you just finish yours. Okay, so go ahead and decide what numbers you want to input.
What are you gonna input for your W? What are you gonna put for yours? Oh boy, here we go. I don't know, let's do 50. Now you do your theta since it chose W. Um, 12. Let's do 36 for that. What are you gonna do for your S? 50. What'd you get? 1760. Yeah. 1,518.9371251.
So you don't agree.
So I probably did something wrong somewhere.
Now, for now, let me come and look at both your codes. Later on, I'll actually have you work collaboratively. Our table should arrive, I thought today, maybe tomorrow. When tables arrive, we can actually have the internet connected where you to the table, so you both can be sitting close to each other. Because I want to teach you to work as a team.
Don't worry, don't worry. Let's see. He's probably a little better than me, so I probably did something wrong on this. And all those values, you got F times S times cosine of theta.
Now you're not converting your theta to radians.
Yeah. That's good.
F times S, and you're converting your theta. So that's where yours is
Yep.
wrong. Again, here's how you change convert to radians. How long did that take me to look at his program and see what he done wrong?
About 5 seconds.
5 seconds? Yeah. This is why it's important if you go into programming career that you learn to work with other people. because you can look at their code sometimes and say, "Oh, you did this," and they can, and then vice versa, and save tons of time. You could perhaps spend 2 hours trying to figure out why isn't this working? Why isn't this working? And then have another set of eyes just look at it and point out exactly what's going on. Now you're not going to do that constantly. You know, you won't be over each other's desk every 5 minutes. Like, what am I doing wrong here? But it's nice to understand the need to collaborate on those. Now I'm gonna create a Dropbox on that, and then I'll show you how we're gonna turn it in temporarily, since it won't let us zip it up. Um, hmm, what? It let you zip it up?
Yeah, Sam. With my other one. With the one that you had to zip up, yeah.
So you could zip it up. I just can't.
Yeah.
Oh, that's insane. Okay, well, I guess I can just show you. I can just put it out here and you can upload it then. That's funny. Where do you guys? Did you save it on your desktops?
Yeah.
Huh. You didn't?
No, I didn't save it to my desktop. It just went to my file, and then I copy and pasted it onto the desktop, and then I zipped it.
Huh. Well, that's gonna be a puzzler for tomorrow.
Files too, pretty sure.
The what?
Like, I have my USB plugged in, so I have it going into my USB.
Oh.
And in the files, you can just send to, and then just press zip folder, and that works.
I've never had any trouble with zip folders before. Because I zip things up all the times at home. Let's see, project. This is the what were we figuring? W work, I guess.
Yeah.
So work calculation. And let's see, 25 points. And okay, so if you go out on Blackboard, you should see the Dropbox there for it. And if you click that, there should be a submit or upload or some kind of button where you can turn that in. So go ahead and zip up that folder if you haven't already, and then upload that work. And then after that, we're going to look at the if statement. See how in the world does that work. Okay. Now, the purpose of an if statement is such that you can compare something. I'm going to leave here. If I'm hungry, I'm going to go eat. Otherwise, I'm not going to go eat. So that's kind of the principle behind it. In terms of a game, you've seen the Space Invaders game? I think I've asked you that. The 2D game? Yeah. Oh, no. I don't know if I ever made it 2D. I probably did.
Nah, yeah, I thought you were gonna say like 3D or something.
Yeah. 3D is different. But the 2D was such that if you develop it, you could have just two images. One where it's feet out, one where it's feet in. And as it's moving across the screen, you'll see the feet go back and forth. That you can accomplish with an if statement, very simply. You keep changing the value of a variable. And then depending upon the value of the variable is which image do you display. So that's where it is from a game development standpoint. Generally, this is part of decision making. So we're talking about structures dealing with decision. You say if, and then you got some kind of condition you're checking here. If that's true, then you're going to do some kind of code here. If it's not true, you're going to do some kind of code down here. For example, if I am hungry, um, then when I leave here, I'll go to Sonic and order, and then I'll eat. Else, if I'm not hungry, this is a true or false type relationship. Then I'll go home. So that's kind of our setup on that. Now this implies if I'm hungry, I'm going to go to Sonic, I'm going to order, I'm going to eat, and I'm going to sit there the rest of my life. So what else would need to be there? Go home. Yeah, drive away. Sometimes you have to figure out, well, if I'm always going to go home, do I even need that inside this if structure? And you don't. If this says go home here, this says go home here, then you can simply put go home down here after that. Sometimes I find myself programming poorly. I'll have if statements and else statements, and I'll have the same code here as the same code here. If you have the same code in both places, you might as well put it outside of the if statement. It keeps it a lot simpler and easy to work with. Now we're going to figure the average. So what we're going to do, ghosts. We're going to take three numbers like 3, 5, and 8, and we'll figure the average. Is it windy out?
Yeah, must be. Must be windy as well. Trees are I thought it was like
No.
class next to us or something.
Actually, there's nothing over on that side. Okay, so let me start a new project. Do a file, new project. I'm going to choose the console app.net framework again. And I want to bring in three numbers. I want to figure the average. I'll make them doubles. Just to, because I know I'm going to have decimals probably, so I might as well just go ahead and make them doubles. I'll call them num1, num2, num3. Now I need to bring those three in. So I need my console dot write, and I could do a write instead of write line. Write stays on the current line, and I'll say input number 1. And I'll say num1 is equal to double dot parse, beginning parentheses, and then I'll say console dot readline, beginning parentheses, closing parentheses. I would recommend, until you get really comfortable with this, that you always write the code. You always type out the code. What you can do after you get comfortable with it is this 2 lines of code here is going to be the same for my next 2 numbers, isn't it? With only a couple of changes. So you can edit copy and edit paste that in. By typing it each time, you get it cements it in better. So I got console.write, and I'll say input number 2. And I'll say num2 is equal to double dot parse. Now again, as that's popping up, be sure to use your code completion. I've typed PAR, do your tab key to complete that out. Sooner you get used to that, then the easier your programming is. I hated that when I first started programming with code completion. because I'd be sitting there just typing along, happy, and then all of a sudden these windows would pop up on my screen, and it would just like startle me mentally. It's like, whoa, what happened, and so forth. But once you get used to it, you love them. Just simplifies coding. And then I'll say console.write input number 3, and I forgot something. Forgot to put my, what did I forget? Oh, my beginning. And I'll say num3 is equal to double dot parse console dot readline. I just think it from an engineering architecture standpoint. If you design it a certain way, does it cause the wind to make it really loud like that? Okay, now average, I need a variable called average. Now we'll calculate the average. So average is equal to num1 plus num2 plus num3 divided by 3. Now we're going to talk about this because it's wrong. But I want to ask you what's wrong about it. Just the last line I just did.
I'm guessing it's because you have number 1, number 2, but in input you have number 1, number 2.
No, that's fine because this is num1 here, num2 here, num3. Remember from algebra, we had order of operations. And there was a please excuse my dear, oops, let's do that right, my dear Aunt Sally. Parentheses.
First,
Then exponents. And then M and the D. Multiplication and division. Then addition and subtraction. The way it's written, it's going to do multiplication and division before it does addition and subtraction. So the way this is written, it'll come through and do this num3 divided by 3 first. And then it'll add that result to num1 and num2. How you get around that is you put parentheses around num1 plus num2 plus num3. Parentheses from a programming standpoint, or actually even from an algebra standpoint, says do whatever's inside the parentheses first. So now it's going to go through and add num1 plus num2 plus num3 inside the parentheses, and then divide the entire thing by 3. Now, you do not have to be an algebra wizard in order to be a computer programmer. Oftentimes, I wasn't sure of the order of operations, so I would simply just put parentheses there just in case. Extra parentheses do not affect your program. So if you know you want to add those first, go ahead and put it there, and you don't have to worry about your college algebra days. So now we're ready to print our answer. So I'll say console write average is, and then I'll say console write line, and I'll say average. Console write again stays on the current line. right line causes it to go down the next line after it gets done printing. And I'm gonna, what am I gonna do? 3, 5, and 8. 3 plus 5 is 8, plus another 8 is 16. So I got 16 divided by a total amount. I got 3 numbers. I don't know what that's equal to. Is 5 point something. I didn't bring my calculator to class. So when I run this, I better get 5 point something. So let's see.
9.3 continuous.
Oh, is it? Okay. Click start. Oops, wrong one. I'll click debug. Start without debugging. And no memory. What did it say? 3, 5, 8. So put in 3, 5, and 8. And like you say, 5.3 is going on forever. Now you would know you got the wrong answer if you did not have the parentheses there. If you took those parentheses away and ran it, you get the wrong result, and that's where you'd scratch your head and say, "Well, what's going on here? Why is this not working?" And we're going to take a look at debugging tools later on to help you figure that out. But what I really want to show here is the if statement. Let's say instead of just being random numbers like that, they're test grades, and you want to see if you passed. Well, here I'm going to do an if statement, and then do a beginning parentheses. And we're going to compare, so I'll say if average is greater than, let me do equal to also 70. Then I'm going to display console.writeLine, and I'll say you passed. Greater than just mean, is just like you'd think, greater than that number. By putting the equals to the side here, that's checking to see if it's also equal to 70. Because if you got 70 or greater, that means you passed. What happens if you didn't pass?
You failed.
You failed. So I can put an else statement here, and then do my lines and say console.writeLine, you failed. Now, if I ran this, did everybody get to that point? Okay. If I run this, I do debug, start without debugging. It says input first number. Let's say I got a 50% on the first test. So put 50 in there. Second test, I got a 40%. I studied really hard on the third test, and I got a 95. Then if I press enter, it tells me my average came out to 61.67, and it says you failed. Press any key to continue. As I taught math for since 1994, whatever years that is, 24 years approximately I've been teaching math. And I'd always get that question. People would ask me, what do I need to get on the final exam to get a C in the class? Because it be doing bad on the test. I could sit here and write a program to do that. And then I could put it out there for them. I could even throwing in a game. It's just like, well, when would you ever want that in a game? Never mind, you wouldn't want it in a game. Um, where would an if statement work in a 2D game?
Well, if you got this character, you won. If you lose this character, you lost.
Yeah,
You failed.
you could use that. There's actually a lot of different situations. Lives. You ever play those games where you get like 5 lives to start with? You die, you get 4, 3, 2, 1, 0. What ends the game is constantly checking that. Yeah, if lives is less than 0 or less than 1, game over. Um, Positioning on the screen. If you wanted to have total control over that yourself, you could have your own checking your position of your character versus the position of other objects, and then you can handle it appropriately. You just use if statements over and over. If you had a collision, and sometimes the if is built in, like it'll have an event handler in a game, and if you've had a collision, then it'll do this bit of code. Now let's change this slightly. I mean, that's really nice. But I'm going to put another if statement down here to tell them what their grade is. So if average is greater than or equal to 90, we're going to say console.writeLine. What grade did they get? You got an A. Then I'll do a down arrow. And I'll say else if average is greater than or equal to 80. Then console.writeLine, you got a B. Now go ahead and put the next 2 lines of code to handle C and D. Oh, wait a minute, our class time's over. 5 minutes past, jeez. Never mind, that's good enough for today. Was that is that good? Okay. So let me go ahead and save the recording here.